Good morning, all. Welcome to the next part of chopper circuits. So, in the last class, we have been discussed few questions, very few questions, and I think I had given one practice exercise question. How many of you did that? Just drop your answer in the comment section. Next part of let's see. Let us continue. I think this is the one that we saw in the last class, right? I hope you all remember it. So let us continue with that. Um, what is the question? First of all, what is asked? The question that is asked is the chopper circuit shown in the figure operates at a frequency of 150 hertz. Okay, its on time is given that 5 millisecond. Then its output average current also given. Yes. Peak to peak ripple current. Yes, that is also given as 5 ampere. Then the question is, what is the average value of the diode current? Yes. How many of you got the answer for this? You can keep your answer in the comment section if you have got it. See, I have asked so many questions how to calculate the. See, for this, just previous question, right? Just previous to this question, we have been solved all these things. How to calculate the average value, RMS value, especially for buck converter. Given it is once again they have given buck converter only, and you know how to draw the waveform, right? I have been told you first your switch will be on, then inductor will be charging from minimum value to maximum value, then freewheeling diode will turn on, then inductor will be discharging its energy through the resistor with the help of freewheeling diode. That is the second circle. So the first of is switch will turn on, that is called conduction period of thyristor, whereas our freewheeling diode will be turn off, whereas in the second off this is called off time period of the thyristor. Thyristor will be turn off but our freewheeling diode will be in conduction. And we saw the relation between off time and total time period. Off time equal to 1 minus delta, that is a duty cycle, delta times of fundamental time period t. Yes or no? We have seen, we have been observed this. Similarly, we also saw the relation between on time to total time in terms of duty cycle. That is T on equal to delta times of T. That is the basic fundamental relation. Now the question is, suppose if you are requested to calculate the average current of the thyristor, sorry, of the diode. So if the peak to peak, see there, they have given peak to peak ripple current here, but that data is not required. Why? Because they have given the average value of the current. Sir, what is the actual meaning of average value? Average current means addition of minimum value and maximum value divided by 2. So this average current is given in the off time. How much it is? It is clearly given as 5 ampere. With the help of this, it is very easy to calculate freewheeling diode average current. How will you estimate it? If you want to know the value of average value of the freewheeling diode current, how will you calculate? We have to take the area. Area means height into width. Height means average output current into its correspondent with this off time. I am talking about only freewheeling diode. Freewheeling diode conduction period is this one, off time, out of total time. This is the completion of one complete cycle. Now it is very easy to calculate. Output current I naught is how much? It is 5 ampere already given. Into, if you observe, on time is given, frequency is given. You know how to calculate a delta. From frequency, we can calculate the fundamental time period because both are reciprocal to each other. So if I will keep 1 upon 150, that will give you the value of fundamental time period. Yes, of course, we can do. From this, if you are trying to estimate the value of delta, how will you estimate? That is on time upon total time period. Whereas on time is 5 millisecond. Milli means 10 power minus 3 upon fundamental frequency is 1 by, that is a fundamental time period is 1 upon 150. So it will come to the numerator. Yes or no? Now tell me, what is the value of 5 times of 150? It will be 650. I hope I am correct. Right? For 2 times of 150 will be 300. 4 times, sorry, it is 750. 750, forgive me. So totally 750 into 10 power minus 3, or we can say 0.75. So the value of delta we got. Now we know T off can be replaced by 1 minus delta times of fundamental time period T upon T. So it get cancelled. Directly replace delta by 0.75. 1 minus 0.75 will become 0.25. 0.25 is known as 1 by 4. 1 minus 0.75 will be equal to 1 by 4 only, right? 1 by 4 means 0.25. You can cancel it. It will become 1 point. Remainder is 1. Again 2. Again 2 times of 4 will be 8. Again remainder will be 2. 5 times of 4 will be 20. So exact value is 1.25 ampere. This is average value of the thyristor current. Sorry, diode current. Suppose if I am asking RMS current, how will you do? RMS current means take the average current, square it into corresponding time period upon fundamental time period. Keep all these parameters under root. From this you can take output current I naught. You know T off can be replaced by 1 minus delta times of T like this. So TT will get cancelled. So in under square root you will have only 1 minus delta. So the value of delta is 0.75, we know. 1 minus 0.75 will be 0.25. So it can be written as I naught into 0.25 or 1 by 4 under root. 1 by 4 under root. What is the equivalent value? Its equivalent value is 1 by 2 only. So I naught by 2. What is the value of I naught? 5 ampere. 5 by 2 is what? 2.5. Sir, we can get different del values from the given data, sir. From the figure, V naught equal to delta times of Vs. V naught, okay. And also by using frequency and T on in the given data, how can we take the right value of delta? Output average current is given. Okay, let me check. The value of V naught equal to, basically we will be calculating output current I naught into resistor R, whereas the value of average value of the output current is 5 ampere into resistance is 5. So this will be equals to 25. So if you calculate the value of delta, this is a buck converter, right? So V naught equal to delta times of Vs, or we can say V naught by Vs. V naught value is how much? 25, whereas the value of input is 250. So I can cancel it. 0.1. Okay, there is some mismatching in the data. No, this value would be same, ma'am. You have to observe here. There may be, they haven't observed while giving the data. No issues. Uh, Remove any one unknown values, any one known values. Keep it is R. Assume that the value of R is not known. I understood that you are saying that output current is okay, whatever it is, because even if you take 10 ampere also, 10 times of 5 will become 50. Then if I will cancel it again, it will become 0.5 only, right? So it is not required. We can leave that data. Remove this resistor by 5 ohm by unknown value such that you cannot calculate it through this way. Use only this method. See, delta value you can't obtain from here on data, from here on data. It should be fixed because it is time ratio control. With the help of time, we are trying to control the output voltage only. So they are directly depending on each other. We can't say we can get two different value. It is not possible. Okay, maybe some mismatching in the data. Unknowingly, they might have given the resistor value. Chal. Let's go ahead with the next question. So I can say that is the next question is 1 minute. A chopper. Okay. The figure is given. A chopper shown in the figure. The 1 minute. Yes. The chopper shown in figure. The chopper shown in figure has the chopper shown in figure has load resistance RL or output resistance. They told it is 0.5 ohm and supply voltage Vs equal to 200 voltage. It is given, and battery voltage E, it is equal to 50 voltage. This is also given. Now the average output current I naught also given as 100 ampere. Okay, now fundamental chopping frequency F, frequency also given as 100 hertz. The value of the load inductance L, value of the load inductance L, which would limit the maximum load ripple current to 5% of I naught. See, the value of inductance is that dash, which will which will be which will be limiting which will be limiting the maximum load ripple current. You know how to represent this. Maximum load ripple current equal to 5% of output current. You have to identify the desired value of inductance such that that resultant inductance will going to control the maximum limiting current. We know that is maximum load ripple current. This is called, you can write down, this is called maximum load ripple current. So maximum load ripple current will be limited to 5% of I naught. 5% of I naught in the sense average current of output only. So the maximum ripple current will be limited to 5% of I naught current. How it is possible, sir? They made it by keeping some desired value of inductance. Now you are requested to calculate that unknown value of inductance only, whereas the diagram is given. So this is R, this is the battery, this is the given circuit. Of course, diode is mandatory. It will be placed here. You know, it is as usual buck converter only. There is no big changes still. So this is battery. This is the inductance L, and this is buck converter. See, they are trying to measure the output voltage across this. See, they are treating this whole part as a load. So now they are trying to measure the voltage across this. So you know, inductor will be basically behaving as a short circuited one. So it is very easy to calculate. You can directly say that if I will measure the voltage across these 2 points, see here between these 2 points, or if you are measuring across the voltage between these two nodes, both will give you the same result because the inductor behavior will become short circuited one when it is connected with the DC supply. So input is as usual connected with the supply voltage Vs. Okay. Now you can start your operation. Try to figure out the value of inductance L. That's all. It's a direct question. I hope you all know the formula. No, don't take much time. How to calculate the first of all, okay, I don't want to give any clue. Try it by yourself. Take 2 minutes, then we will see the answer. If you got the answer, immediately drop it in the comment section because I'm waiting for your answer. Okay. Guys, one small correction. This battery voltage is 5 voltage. Forgive me. I know I made a confusion. It is wrong first of all. You can't keep 50 voltage there. It is 5 voltage. I haven't noticed the question properly. Sorry. Geeta, point one. No, calculate if voltage is 5. Then what can be the answer? Uh, Everyone, try your best. Drop your answer in the comment section. Fast. Make it fast. It's a direct question only. No? I don't know why you people are spending this much time. You guys are having everything with you. Okay, tell me, what is the maximum ripple current here? What is the maximum ripple current? Del V naught. Anybody? Okay. Uh, let's see. I don't know how many of you got the answer, but let me try to figure out the answer. See, question is what is the max, what is self inductance, right? Such that output current will become 5% of the total 0.07975. Good. Okay, listen. We know we can easily calculate the maximum ripple current. Either it is current through the inductor or current through the output, both are same. The maximum value of ripple current through the inductor. How will you write down this? We should focus only on maximum ripple current. You have to understand this. Del I naught maximum. Only we should focus on maximum value, not upper to lower limit. Maximum ripple current means our inductor current will be charging. It is reaching its maximum value, then it is going to minimum value again. So during this rippleness, what is the maximum peak value? Ripple maximum. So for that, the direct formula is what? We can write supply voltage Vs upon 4 times of inductance L into frequency F. We might have calculated this, right? Now you can substitute all the values. See, what is the del I naught maximum here? Let me substitute. The question given it is only this maximum point. Remember, okay, this maximum value is 5% of the output current. I can say 5% means 5 into output current I naught upon 100. Yes, it is 5 ampere equal to supply voltage. How much? That is also given 200 voltage divided by 4 times of inductance L is not known into frequency F also given, that is 100 hertz. That's all. Now it is very easy. Output current I naught also will be 100 ampere. Anyway, this LHS and RHS hundreds will get cancelled. I can cancel this also. It will be equal to 2. And if I will cancel it, this will also will become 2. Finally, if you estimate, 5 ampere equal to 1 upon 2 times of L. So the value of L equal to 1 upon 2 times of 5 will be 10. So 1 by 10 will be equal to 0.1 Henry. Or I can say it will be 100 millihenry. That's all. That is the actual value of inductance. If you keep this value, it will be helping us to maintain the maximum ripple current as 5% of the output current or average output current. That's all. Okay, just note it down. Chalo, sir. Now let us move on to the next question. I will be bringing some new things. I told you, if anything is not there, if you find anything new in the lecture, just to make a note. That's all. உடனே ரொம்ப ஓவரா ரியாக்ஷன் பண்ணாதீங்க. ஓ சார் இதை நான் பார்க்கவே இல்லை, அங்கே பார்க்கலீங்க. No issues. I told now one or two things might be missed. You might be missed or something might be missed in the lecture somewhere. But while solving the problem, if you find anything new, immediately make a note. That's all. Sure. So let us go ahead with the next question. The next question is a battery, given it is a battery with the terminal voltage. A battery with the terminal voltage. A battery with the terminal voltage of 200 volt. A battery with the terminal voltage of 200 volt is supplied power with the first quadrant chopper. Is supplied power with the first quadrant chopper. First quadrant chopper. Okay, sir. Now what they given is the on time of the chopper is given, that is 2.5 millisecond, whereas the off time of the chopper also given, that is 3.5 millisecond. The on time and off time of the switch is given, and the RMS value of the fundamental component output voltage is dash. What is the RMS? The RMS value of fundamental output voltage V01 is dash. That is the question. See, what is the given data is a battery with the terminal voltage is given, is supplied a power with the first quadrant chopper, everything is given. The fundamental RMS output voltage is dash. That is the question. If you have any idea, you can try first. Then I will give you the answer. It's basically related to the harmonics. I will write down the formula. See, you might have read this harmonics formulas even in inverter circuits. Let's see how far you people understood the power electronic circuits. Try and drop your answer. Anybody got the answer? Just try. See, for the battery, output battery, they haven't given any internal resistance, that is neglected. So no need to be bothered about it. the answer? Anyone at least tried sir beat it in this way? Okay, let me write the generalized expression for this. Keep smile in your face and be active. Sir, a battery with the terminal voltage is given. Terminal voltage means what? That is supply voltage of the seat. A battery with a terminal voltage of 200 voltage is supplied a power with the first quadrant chopper. It was clearly given. Okay, sir. From this, what we can identify is the fundamental voltage is supply voltage is clearly given, that is equal to 200 voltage. First conclusion. Okay, sir. What can I do with only this data? Let's see what can we do. Okay, supply voltage is given and they have given on time and off time. With this, I can calculate the fundamental time period T. Fundamental time period is 2.5 millisecond plus 3.5 millisecond. 2.5 plus 3.5 will be equal to 6 millisecond. Yes or no? Yes, sir. Now we know rest of all. Sir, how do I express this fundamental? First of all, the thing is in the output side we are receiving rectangular waveform. If you find out the Fourier series expansion with respect to time for the output voltage, for the rectangular waveform, you know our output voltage is always rectangular. You all know. If you observe the output voltage, how it will be for the first positive during the on time, it will be like this. After that, what will happen? Our voltage, when the moment you are switching off the circuit, we are trying to control the output voltage. It's a rectangular pulse, right? For the rectangular pulse, if you expand the trigonometric Fourier series expansion, it will give you delta times of VDC plus summation. Again, you can write n equal to 1. I have to start from n equal to 1 because n equal to 0 we will be obtaining DC component alone. Basically we will be keeping our attention only with the DC component. If I will express rest of all waveform, remember one thing, I am not doing anything apart from the expression. The output waveform that we are receiving with the help of chopper is rectangular. For the rectangular waveform, basically anywhere, it doesn't matter whether you are in chopper or in any other circuit. For the rectangular waveform, if you express the output in uh, in case of inverters, there also we will be using one technique is called pulse width modulation technique, PWM. There also you might be observing similar kind of formula. So n equal to 1 to infinity, you can observe 2 VDC upon n pi, because in inverter, it may be in off wave control, full control, everywhere you can observe that your output waveform will be expressed in terms of fundamental waveform expression, it will be in the same form. So 2 VDC into sine n pi delta into sine n omega t plus theta, sine n times of omega t plus theta. That is the generalized expression for the rectangular waveform. Don't think too much, sir. I found this formula only in inverter. How can you write the same formula here? Because here also I am doing the same in the output side. I am trying to express the trigonometric Fourier expansion for rectangular waveform. Fine, sir. Now, which one is called fundamental? Output fundamental in the sense at n equal to 1, that is called fundamental expression. N equal to 1 means, see, if you take this expression, fundamental RMS voltage. If you observe, this is at n equal to 0, we are receiving this one. This is output DC waveform. Fundamental means at n equal to 1, we will be receiving this expression. Replace n by 1. This is sine omega t. See, this is instantaneous voltage expression. Just observe, the instantaneous voltage of AC waveform will be represented as V of t equal to Vm sine n times of omega t plus theta. Actually, n equal to 1 here. This is fundamental. So, sine omega t plus theta. Whereas this is called Vmax. In place of Vmax, we are having this much term. So I can say the fundamental Vmax at n equal to 1, fundamental Vmax 1 equal to 2 VDC upon pi, sorry, 2 pi. It should be n pi, right? N equal to 1. It is, sir, it is not, yeah, it should be n. N equal to 1. If I will replace n equal to 1, that will become 2 VDC by pi into sine pi times of delta. Okay, sir, this is maximum fundamental voltage. I need fundamental RMS voltage. We know fundamental RMS, it should be equal to what? I can write maximum fundamental voltage divided by root 2. This is how we are obtaining RMS voltage. So take the same expression 2 VDC by, take this expression divided by root 2. If I will divide it by root 2, then that will give you the value of fundamental. That's all, it is over. So now replace pi by 180 degree because we are calculating sine of theta into what is the value of delta. Do you know the idea? Do you have any idea about delta? So this VDC is known, how much it is supply voltage, that is 200. VDC is given as 200 voltage, sir, but how can I calculate the value of delta? We know delta equal to on time upon total time, whereas on time is given as 2.5 millisecond 10 power minus 3. Total time is 6 times of 10 power minus 3. Now 10 power minus 3, 10 power minus 3 will get cancelled. You can keep this 2.5 by 6 in this place. That's all. If you reduce this expression, you'll be getting, see, 2 by root 2. It will be, this 2 can be written as root 2 into root 2. 1 root 2 will get cancelled here. So further we can write root 2 times of VDC equal to 200 voltage into sine of pi. Its equivalent degree value is 180 degree into 2.5 upon 6. It is in degree. Now, what can be the resultant expression? See, 2 can be, root 2 can be written as 1.414. If I will multiply it by 2, then that can be written as 2.828. If I will multiply it by 100, then it can be written as 282.8. So it equivalent value is 282.8 into sine of 180 degree into 2.5 by 16. So our next target is we have to estimate this value. Okay, I'm also going to calculate this value to check the answer. You guys also can try. I just wanted to know the value of 180 into 2.5 upon 6. If I will take sine for that, 0.9659. I'm getting this whole equivalent value is 0.9659. So again we have to multiply it by 282.8. So I'm getting 273.16 voltage. This is how we are obtaining fundamental RMS output voltage. So from this moment onwards, if you have not aware of these things, sir, I don't know basically how to calculate this. If you don't have any idea, do remember this expression. This is the general Fourier series expansion of the what I can say, rectangular waveforms. Okay, fine, sir. Let us let us go ahead with the next question. So this is the next one. The circuit shown in the figure, duty cycle. This is delta. Okay. Sometimes people used to give alpha. Also, don't get confused. It is depends on the person. Okay. Okay. So delta equal to 0.5. Input voltage is given as 200. Then what is the value of output voltage? That's all. Do it fast. You know what type of converter it is. We will be having three type of converter. This is one of the amongst three. Try and figure out the answer. What can be the expected output average voltage for the given circuit? Do it fast. Anyone? Geeta 200. Very good. Any other? Any other answer? bring to 200. Good. Any other answer? Sure. So let me try to bring out the answer. So it is a very easy question. We know the value of V naught average can be written as delta upon 1 minus delta times of source voltage. Sir, how did you return it? What type of converter it is? Tell me now. You all know this given converter is buck boost converter. Yes or no? Yes, it is buck boost converter. In case of buck boost converter, this buck boost converter can act as a buck converter and it will also be acting as a boost converter. Suppose if I am keeping the value of delta equal to 0.25, what can be the expected output voltage? Do you know? Let us see. If I will keep the value of delta equal to 0.25, it means it will be equal to 1 upon 4. Let us substitute that. Then the output voltage V0 will be delta is given as 1 by 4 upon 1 minus 1 by 4. It will be equal to 3 by 4 into supply voltage Vs. So I can write it will be 1 by 4 upon 3 by 4. 4 will be cancelling out into supply voltage. So I can say it will be Vs upon 3. It clearly indicates that the value of output voltage will become 1 by 3 times of input voltage. Input voltage is already given as 200 voltage. If I will divide it by 3, then you will be getting, what you will be getting? It will be very easy to calculate. So it will be 6 times of 3 will be 18. So I can say again remainder will be 2 again 6 times. So 66.666 voltage. But it clearly indicates that the output voltage is less than the value of supply voltage. It means when the value of delta is less than 5, then it will be acting as a buck converter. Okay, sir. I understood that. Let us go ahead with the second case. So when delta is less than 0.5, then buck boost converter will act as a buck converter. Suppose if the value of delta is greater than 0.5, then what will happen? That is my question. Again, if you estimate the value of output voltage V0, let us consider the value of delta equal to 0.75, which is greater than zero point 0.5. 0.75 can also be written as 3 by 4. Yes. So V0 equal to delta upon 1 minus delta. Delta is 3 by 4 into supply voltage Vs. Now what will happen? 3 by 4 into 1 minus 3 by 4 will be equal to 1 by 4. Yes, sir. If I'll do the cross product, 4 minus 3 will become 1 only. So 1 by 4. Once again, this 1 by 4, 1 by 4 will get cancelled into Vs. If you observe, output voltage will become 3 times of supply voltage. It means if the input voltage is 200, then output voltage will become 600 voltage. What we understood, if the value of delta is greater than 0.5, I can say this is acting as a boost converter. Boost means output voltage is greater than input voltage. So I can say when delta is greater than 0.5, it is acting as a boost converter. Sir, suppose if the value of delta is equal to 0.5, then what will happen? Again, estimate V naught equal to delta upon 1 minus delta into supply voltage Vs. See there, 1 minus 0.5 will be equal to 0.5. So numerator 0.5, denominator also 0.5, 0.5, 0.5 will get cancelled. So V naught equal to Vs. So what we understood, when delta equal to exactly 0.5, then if the input and output both are equal, then that circuit is called what? We will be calling it as buffer. Yes or no? So it is acting as a buffer. So basically it is possible to bring three types of output voltage, but we are not interested in this one, because when output and input voltage are equal, then what is the point of keeping that circuit? We will be designing these buffer circuits with the help of operational amplifier in analog electronics in order to bring the ideal voltage source. You might be observing this. So we are designing, but not here. Its application is there, but in analog electronics, especially in operational amplifier circuits. There also one buffer circuit is there. Basically, that will be used to convert your voltage. You might be remember that circuit. If I'm having a practical voltage source, then the practical voltage source will be considered like this. See there. Basically, what will happen? Equivalent circuit of practical voltage is voltage with the internal resistance. It is in series. This is the equivalent circuit of the practical voltage source. I am connecting it with the non-inverting terminal. Okay, the inverting terminal is connected with the output. Now, what can be the expected output voltage here? The current consumed by the operational amplifier is 0 ampere. Feedback is negative feedback. Assume operational amplifier is ideal one. So ideal one means gain of the operation amplifier is approaching to infinity. Then the input current flowing through the circuit will be 0 ampere. If the current entering into the operation amplifier is 0, then what is the expected voltage drop here? 0 ampere into 2 voltage drop will become 0 voltage. So there will be no voltage drop across this internal resistor. So what will happen? Across the positive terminal, you can achieve this 10 voltage. Directly it will be reflected here. When operation amplifier is ideal and gain is approaching infinity, then voltage across the positive terminal will be equal to voltage across the negative terminal. So what will happen? Same 10 voltage will be reflected across the inverting terminal. So V0 equal to, so this is V0. Here also it will be V0 only. Here also it will be V0 only. So this V0 is basically equal to V minus in this circuit. V minus means voltage across the inverting terminal. Voltage across the inverting terminal is equal to voltage across the non-inverting terminal. So I can say output voltage equal to simply 10 voltage. See there, we got the output voltage without considering the effect of internal resistor. So what is the conclusion? Practical voltage, now a practical voltage source is behaving as an ideal voltage source. Yes, it could be possible with the help of this circuit, also called a buffer only, because the output is simply equal to supply voltage Vs. This is one of the application. But in buck boost converter, it is we are not using it much. Anyway, in the given question, they have covered this, so I just covered the rest of all things which is required here. Okay, so basically this circuit will behave as a buck converter, buck boost converter. That is buffer also, right? So now do remember these things. Sometimes in the examination, especially in some small exams, state government exams, they will be asking this kind of direct questions. If you do remember, you can directly substitute. Okay, fine, sir. Shall we go ahead with the next one? Let me bring the next question now. 1 minute. Yes, sir. Given it is, we are considering once again there is a battery. We will be writing like this. Let us consider for a type A chopper circuit. Type A chopper. Type A chopper. It is feeding RLE load. Connected load is RLE load. Now the question is, what is the maximum value of the average current rating of the thyristor? So we have to calculate the maximum average value of the thyristor current. Thyristor current on the maximum evaluable. That's all. Thyristor current. If the load output current is constant. When output current I0 is constant, then what can be the expected average value of the thyristor current in case of type A chopper circuit? That is the question. Okay. Whereas they have given some data. The value of battery voltage is given as 50 volt, and the supply voltage Vs also given as 80 volt, that is also given, and the value of resistor also given as 0.5 ohm. That's all. Now you can substitute the answer, that is you can drop your answer. Type A chopper connected to RLA load, the output current is constant, all other parameter is given, then what is the expected maximum average thyristor current? That's all. Try and figure out the answer. It is a easy question only, and it is little tricky also. Type A means you can almost equate it with our buck converter. Both will be almost giving the same result only. Circuit wise, I'm telling you can draw the output waveform. Current waveform will be similar. Voltage waveform also will be similar for type A chopper and buck converter. So if you have any doubts, you can just in free time just to go through about type A chopper circuit, type B, type C. What is this classification? And, don't go too much deep. Depth is not required. Just basically what is the relation and how to draw the waveform. Some small basics you can just go through and make hints. Okay. If you find anything new, immediately make a note. Don't forget, that's very important. I had given the clue. Its output waveforms, voltage and current waveforms will be similar to our buck converter. Then load also given, all other parameters given. If both are similar, then how will you estimate the average value of the output current? We have been seen about a buck converter many times. How to calculate the average current, RMS current for both freewheeling diode and switch. I have written the expression and I have shown you how to do that. So I'm expecting the answer from your side. Let's see what you people will do. Okay, listen. Let me try to bring the answer for this question. Sorry. I told you its output waveform is similar to our buck converter. So in case of buck converter, if I will draw the output waveform, how it will be? If you draw the current waveform, basically, what will happen? Sorry, output voltage waveform. Let me switch on the circuit V0. You can observe it will be 1 minute, guys. Yeah, they clearly told that the output current is constant, first of all, right? Then you can draw the output voltage. This output voltage will be continuous, but how it will be? The thing is, first we will be receiving output voltage with the help of switch. You know how to draw the buck converter, but I am going up with the type A chopper, that's why I haven't drawn here. During the on time, switches will be on. Again, you can see the remaining will be flowing through the diode. Again, same circuits. If I will draw the what I can say, 1 minute. If I will draw the output current is constant. They told, okay, sir, output current is constant. Then if I will draw the current through the thyristor, when the switch is on, then current will be flowing through the thyristor. When switch is off, then current will be zero. Again, when switch is on, it is. This is the expected thyristor current. Through the thyristor, output current will be flowing. Okay, sir. Fine, sir. This is fine. From this, how do I express the average value of the thyristor current? That is very easy. How, sir? Average means the generalized formula is area upon time, first of all. Now, how will you calculate the area? The total time period of one cycle will be T, whereas thyristor will be carrying the output current only at on time. So I can say now we have to calculate the total area. In the second case, I have the width is off time, whereas height will be 0. Height will be 0. There is no height. So 0 into T off. This is for area formula for the rectangular waveform. So 0 into T off will be 0 because height is 0, whereas in the first case I naught into T on. This is the area formula for the rectangular I naught into T on. So we have calculated the area divided by fundamental total time period. This is the average formula. Whereas, did they given any other data? Sir, output current I naught, simply they told it is constant, but they haven't given any data set. How should I proceed? And one more thing, this is only average current. They are asking what is the maximum value of the average current. Okay, let me ask you from the fundamental. Whenever you are requested to calculate the maximum value of any expression, what will you do? Step number one, they will give you, you have to identify the variable quantity. What is the quantity is continuously varying here. Anyway, we are trying to achieve this maximum value by varying something here. In chopper circuits, we are applying time ratio control, TRC. I told you, time ratio control means by adjusting the value of delta, we are controlling these things. We are trying to achieve the maximum output voltage, minimum output voltage, whatever that we want. We are achieving our desired output with the help of our controlling parameter delta. So here the variable quantity is delta. So if you want to achieve the maximum value, you have to differentiate that expression with respect to delta. Here in power electronic circuit I'm doing in chopper circuit, then equate it to 0, then you will be getting some condition, desired condition in which you can achieve this maximum value. Are you getting me? In general, even in mathematics also you might have seen these things. It is there in every subject. The generalized approach, with the help of differentiating any expression, we can achieve the desired condition in which we can obtain the maximum value. So if you want to know the maximum value of any expression, just to differentiate that expression with respect to the variable parameter or controllable parameter. Then equate it to 0, solve that expression, that will give you some resultant value. Again, resubstitute that resultant expression into the normal expression. That will give you the maximum value. This is the generalized procedure. So I will show you, no issue. So here I can write output current I naught. Okay, sir. The output current I naught also they haven't given any data. First thing, and this T on by T, it can be simply written as delta, because I need this expression in terms of delta only, such that it is very easy for me to differentiate it with respect to delta. Now this output current I naught, how can I write this? Sir, it is clearly given that the output load is RLE load. Even in rectifier circuit also I have clearly told that whenever inductance is given, in rectifier also in the output side we are receiving DC supply. Though you are observing the presence of the inductor, its behavior will be short circuited one. So the output voltage drop across the inductor will be 0. You don't need to consider that effect. So when you are trying to estimate the output current I naught, so between this overall terminal, we are trying to estimate the value of output voltage V naught. Now can you write down the KVL expression for this? The output voltage V naught can be written as voltage drop across the resistor I naught into R plus battery voltage E. That is the basic relation. Output voltage can be written in this way. We have seen the same thing in even in rectifier also. It doesn't matter where we are. If we have DC, then inductor will behave as a short circuited one. You can't observe its voltage drop across it. Okay, sir. From this expression, can I write output current like this? I naught can also be written as V naught minus E upon R. Same formula we might have gone through in rectifiers because the same type of load. So I naught can be replaced by V naught minus E upon R into delta. Sir, why you are writing in this way? Because this is the given data. So I am trying to bring the relation between the question and the given data. That is what we have to do. That is how smartly we are solving the problem. Okay, sir. Further, we know type A chopper. So type A chapter means I told it also resembles the properties of buck converter. So you can also observe if you draw the buck converter means what? The output voltage can be written as delta times of Vs minus E upon R. Can I write like this? Because we know in case of the buck converter, the output voltage V0 can also be written as delta times of Vs. That is the alternative relation for the output voltage. Yes, sir. I have written in that format also. So now this is the average value of the thyristor current. But the question is, what is the maximum value of the average value of the thyristor current? How should I obtain it, sir? So let me expand this expression. Let's see what will happen. If you further expand this, the thyristor value average current, if I will further expand this, we know we will be having delta times of supply voltage minus battery voltage E. Here also we have delta, in the denominator we have a resistor. If I will open up the bracket, delta into delta will be giving you square times of delta into supply voltage minus delta times of battery voltage E upon R. So this is the average value of the thyristor current. Now I just wanted to know at what desirable point, by controlling the value of delta, at what desirable point we can achieve this current, we can achieve the maximum value of this average current. For that, take the current average value of the thyristor current, this expression I am going to differentiate with respect to the controllable parameter, that is our delta. So it will give you 2 times of delta into Vs minus delta into E will be giving you E. Delta will become constant when we are differentiating it with respect to delta. Delta with respect to d delta will become 1 divided by R. After differentiating the expression, I told you to equate it to 0 to obtain the desirable condition. So if I will reduce it further, 2 times of delta into Vs minus E equal to 0, or I can say 2 times of delta into Vs equal to E, or I can say the value of delta equal to E upon 2 times of Vs. See, if I will pass this R to the right side, it will become 0. That's why I am not considering that effect. So the value of delta will become E upon 2 Vs. That is the point where our thyristor will be achieving its maximum value of the current. I hope you all got it. Now, let me treat this one as the equation number 1 and I am treating this one as the equation number 2. I know the thyristor current, average value of the thyristor current will become maximum, will be achieving, average value of thyristor current will become maximum at delta equal to E upon 2 times of Vs. That's all. So now I can write the average value of the maximum value of the thyristor average current will be equal to delta times of see this delta. Now I am reducing this delta will be replaced by E by 2 Vs. So I can substitute E upon 2 Vs into Vs minus E. From the equation number 1 you can observe, don't think too much. I'm just replacing this delta by E by 2 Vs into Vs minus E. Outer side also I'm having one more E upon 2 times of Vs. So whole divided by R. So from this we can cancel this Es. So I can say E by 2 minus E will give you the value of minus E by 2 again. E by 2 in the denominator we have R into E upon 2 Vs. So I can say what I can say, yes. So this E into V, E will become E square. Yes, sir. See, we are considering only magnitude of the current. Now you can ignore the effect of this negative sign. Okay, we just wanted to know the maximum value of the current. Just consider the magnitude and ignore the effect of this negative sign. So such that I'm repeating one more time. I am just considering the magnitude of the current. Okay, so from this magnitude means sign is not required. E into E will become E square. It is already E by 2 means it is also in the denominator only. So 2 into 2 will become 4 times of Vs into R. So this is the desirable formula to achieve the maximum value of the average value of the thyristor current. This is the maximum point. Now let us substitute all the given data. I also don't remember. Battery is 50, supply voltage is 80, it is 0.5. So it is 50, it is 80, it is 0.5. Now let us reduce this. We know 80, if I will replace this 0.5 by 1 by 2, both are equal. It will be cancelled, it will become 40. So it will become 160. 50 square will be 1000, sorry, 2500. Yes, sir. 10 will be cancelled out. Now you have to reduce 250 by 16. So here it will be equal to 15.625 ampere. That's all. This is the maximum value of average value of the thyristor current. So finally we got it. I know it is negative here in the differentiation. I got that. So here in the question they are asking only magnitude. So just to substitute only magnitude of the current. So whenever you will be requested to calculate the maximum value, don't memorize anything, just to follow the procedure. This is how we are achieving the maximum value for anything, Okay, there is no fixed things. Fine, sir. Now let us take a step-up chopper. Question itself it is given that we will be considering a step-up chopper circuit. A step-up chopper with the supply voltage Vs equal to 220 volt. It is given delivered to the 1 minute supply voltage Vs and output voltage V0 also given as 740 voltage. It is given if the non-conduction time of the thyristor, non-conduction, you know the meaning of this. Non-conduction means what? Non-conduction time of the thyristor. If the non-conduction time of the thyristor is given as 400 microsecond. Now the question is, then what is the required pulse width? Identify the required pulse width. Required pulse width would be dash. Now you can take your time, read the question one more time and try to figure out the answer. First of all, just do let me know what is the pulse width. Pulse width means what? What is the meaning of pulse width? See, I will tell you the meaning. Some of you might be confused. What is the meaning of pulse width? Suppose I am receiving the output like this for some duration. I am only talking about thyristor. I am just width means what? How long we are receiving the value. This is called width of the pulse. You know, this is called pulse, one pulse. Yes or no? In case of rectifier, this is called one pulse because our output is not pure DC. I am talking about rectifier. In case of chopper, basically our waveform will be rectangular. So this is called pulse. So pulse width means what is the width of this pulse? That is called pulse. Now you can think about remaining all things because I had given sufficient data. If myself I will give everything, then you won't solve. Do it. You may have some rough idea. Basically, whatever you are having, first try to apply it such that when you observe that there is some mistakes in your calculation, you can change it. Your mind will be thinking, oh, there is some mistake. Okay, fine. I will rectify it. Keep smile in your face. Always be active. Just be conscious. You should be like that while solving the problem. Sure. It's an easy question and direct question. You can try your best for this. Answer please. Are you people are trying? Okay. Shall I try? Okay. Listen. So basically what they are asking is required pulse width. And they are talking about thyristor on time, off time, blah blah. I am just asking you. They are talking about chopper circuit, thyristor, everything is given. Required pulse width means Gita 943 microsecond. Very good. Very good. See, listen. Actually, here the pulse width can be written. Pulse width means what is the on time of the thyristor. I have drawn everything clearly. Then this is going to be the off time of the thyristor. During the on time only you will be receiving something through the thyristor. They are talking about only, see, if the non-conduction time of the thyristor is 400 microsecond, then what is the required pulse width? In the means, in the sense, in this continuous statement, they are talking about thyristor pulse width only. You can observe the width of the pulse through the thyristor only when thyristor is in conduction. Non-conduction means they have given the data about off time of the thyristor only. That's all. Okay, sir. If off time is given, fine. Then supply voltage is given, output voltage V naught, everything is given. How can I express the value of duty cycle? So I just wanted to know the value of delta only. Yes or no? How will you do that? Let me try to help you in that case. Sir, in case of buck converter, the standard expression can be written as V naught equal to supply voltage Vs upon 1 minus delta. Yes, sir. Now our attention is with the on time. So delta is equal to supply voltage Vs by V naught. I can write like this. Whereas the value of Vs is given as 220, output voltage is given as 740. I can cancel this two. We can also reduce it further. 11 upon 37. Yes or no? 37 times of 2 will be 14. 11 times of 2 will be 22. Now, if you take 11 by 37, you will be getting 0.297. 0.2972. I will be taking one more. So from this 1 minus delta equal to this much. I can say minus delta equal to, if I will pass this 1 to the right side, it will become minus 1. So minus 1 plus 0.2972. So if I will subtract this two, I will be getting, it will be equal to minus 0.7027. Minus delta, minus will be cancelled out, so the value of delta equal to 0.7027. That is the value of delta. First conclusion. So delta is okay. This is not the question. I just wanted to know the value of on time. We know delta can be written as on time divided by total time. That will be equal to 0.7027. Okay, sir. Further, it can be written as T on divided by this T can be written as T on plus T off. Okay, sir. That is fine. Equal to, I can say, 0.7027. Any doubts till this point? No, sir. Hopefully it is not. Now from this, if I will take reciprocal for this, it can be further written as T on plus T off. I am just taking reciprocal on both sides. If you take reciprocal for this value, it will be giving you 1.4230. From this, I can further write this expression. See, can I write like this whole expression? I am going to write T on by T on, T on by T on plus T off by T on. Or also we will do one thing. Listen, pass this T on to the right side. That will be similar, simple, instead of going in this way. Again, it will take much time. T on plus T off equal to 1.423 times of T on. This is easy. Now pass this T on to the right side. Again, what will happen? T off will be equal to, if I'll pass this T on to the right side, it will become minus T on. So minus T on plus 1.423 times of T on. Yes, sir. So it will be equal to 0.423 times of T on equal to off time. Any doubts? From this, we need only on time. So on time equal to T off divided by 0.423. 0.423. Okay, sir. What is the value of half time? It is given, half time is given that 400 microsecond. So if you subtract this value with 1, sorry, So what we have to do, 0.423, I have to take reciprocal multiplied by 400, I will be getting 945. So the value of on time will be equal to 945.6 microsecond. Good. Chitra Devi. Yes, you both are got almost correct answer. So the value is 945.6 microsecond. This is how we are estimating the pulse width. Understand the meaning. You know, some technical words might not be, you might not aware of some technical words. What is the meaning of pulse width? What is the meaning of non-conduction time? Non-conduction means off time. There will be no conduction. So that is basically called off time. Whatever the things that you are observing and you are feeling that things are not known by you and some things are new, then you can just. Okay, there is one beautiful question. Next one I'll be bringing now. The question is a chopper. Just observe the question. A chopper operating operating at a frequency f is feeding RL load is feeding RL load. Okay, sir. It is feeding RL load. Fine. Now the question is, if the duty cycle delta, if the duty cycle delta is increased from duty cycle delta is increased from 25 percentage to 80 percentage, they are increasing the level of delta from 25 percentage to 80 percentage, then then the ripple current then the ripple current then the ripple current option A, they told, then the ripple current option A increases. First it will increases, then reach maximum value, reach maximum value at a delta equal to 50 percentage, reach maximum value at delta equal to 50 percentage, again decreases. This is the option A. Then option B, they told, decreases, reaches, then reach minimum value, reach minimum value at a delta equal to 50 percentage as usual, again increases. That is the next option they told. Then option C, remain constant. There will be no changes. It will be remain constant. Then option D, they told, it will be continuously decreasing. Continuously decreasing. It is keep on decreasing. That is option D. Now everything is given. You can try your level best and drop your answer in the comment section. Guys, one more thing. Here they have given that the data is, this is buck converter. Just note down. That's all. Everything is given now. You can try your best. It is buck converter basically. Okay, they have given the data. I forget to give. Try to solve and drop it in the comment section. Anybody got the answer? Option A, Geeta ma'am. Good. Any other? Any other answer can I expect? It is clearly given that is buck converter, but why still you people are not giving the answer? Okay, let me try to solve that question. Listen, it is clearly given that is buck converter, a chopper is operating at a frequency of and it is feeding RL load. Okay. If the duty cycle of delta is increases from 25 percentage to 80 percentage, then what will happen? This is the given question, right? And how will you solve this? Basically, what they are talking, if I will increase the value of delta value, then what will happen to the ripple current? Okay, sir. Now, let me tell you, okay, I'm just asking you, what is the generalized expression for delta current del IL? You all know, I hope you all know, it will be delta into 1 minus delta times of supply voltage Vs upon L into F. Yes or no? This is the generalized expression. Now, suppose if I want to know its maximum value, I know this delta, this ripple current can be controlled with the help of delta only by varying the value of duty cycle. Now, I just wanted to know the condition in which the value of ripple current will become maximum. At what condition? What is the desired condition? At what point this current will be achieving maximum? What is the maximum value of the current? Maximum value of the current and its correspondent delta desired condition. Both I will know. I just wanted to know what we will do whenever we need maximum value. If you want to know the value of maximum value, then differentiate this ripple current with respect to the variable or controllable parameter. See, if you find its inner product, it will become delta into 1 will become delta minus delta square into supply voltage Vs is constant. You can keep Vs by Lf as constant. You can treat it. So I'm keeping Vs by Lf as constant. In the bracket, if I'll differentiate this function with respect to delta, I'll be getting 1 minus 2 times of delta. Then I'm going to equate it to 0. Yes or no? If I equate it to 0, pass this Vs to the right side, it will become 0. This all parameter will become 0. We can say 1 minus 2 times of delta equal to 0. I can say 1 equal to 2 times of delta, or I can say delta equal to 1 by 2, or we can say delta equal to 0.5. So what I understood here is, in case of a buck converter, if the converter is buck, if we are having the buck converter, what I understood is here I can say whenever we are having buck converter, then the ripple current will become maximum when the value of delta, yes, of course it will become maximum when the at I can say at a desired condition at a delta equal to 1 by 2, yes or no? Now let us substitute. We know Vs by L into F is constant. In bracket we will be having delta minus delta square. Let us substitute Vs upon L into F. Delta will be equal to 1 by 2 minus 1 by 2 whole square. 1 by 2 whole square means it will be 1 by 4. I can write further, it will be Vs divided by 4L into F. Yes or no? This is the maximum value of the ripple current. We have been solved one question related to this formula. Do you remember? Just 2 or 3 questions ago, we have been solved one question, right? Related to this one. Wait, I will show you. See there. So here I have been used the same formula. The output current will be achieving its maximum, the maximum ripple current. That is what they given, right? Find the value of inductance for which the maximum load ripple current will be achieving 5% of the output current. This is the maximum load ripple current. We are achieving this value with the help of what? By controlling the value of delta. Yes, so this is how we are obtaining this formula here. Got it? Yes, sir. Everything is fine. Now, what we have understood here, why are you discussing about this activity, sir? Sir, we understood that when the value of delta is continuously increasing from 0 to 50 percentage, I can say from 0 percentage to 50 percentage, what we observed is at a delta equal to 50 percentage. When delta will become 50 percentage, we are achieving maximum value, not minimum value. It clearly indicates that at a delta equal to 1 by 2 only, we got this desired condition. I was trying to calculate the maximum value. I got this value at a delta equal to 0.5. It means what? My inductor is continuously charging and trying to achieve the maximum ripple current when the value of delta will become equal to 0.5. So when the value of delta is less than 0.5, inductor, the ripple current is continuously increasing. After delta equal to 50 percentage, what will happen? We know freewheeling cycle will fall in place. That is, a diode will turn on, switch will turn off. Then the energy that is stored in the inductor will be continuously decreasing. So when the value of delta will become greater than 0.5, I can say the value of current is continuously decreasing. So now if you observe your question, they are talking about from 25 percentage to 80 percentage. What we can say, we can write this statement like this. Sir, from 25 percentage to when the value of delta is increasing from 25 percentage to 50 percentage, I can say the value of delta is continuously increasing. Sorry, I can say the value of maximum ripple current. Ripple current is continuously increasing and achieving its maximum value when delta will become 50 percentage. Further, if you increase the value of delta above 50 percentage, I can say from 50 percentage to 80 percentage, the value of the ripple current again started decreasing. What is the correct answer now? It is continuously increasing and reaching its maximum value at delta equal to 50 percentage. Further, if I will increase the value of delta, then it will decrease. It start decrease. Very good. The correct answer is option A only. Chalo. Now, let us go ahead with the next question. I think I have, yeah. This is the question. What they did is, they have given a chopper circuit shown in the figure. Let me draw the circuit first. Again, there is one inductor, resistor, battery, everything is given. Okay, and the value of inductance is dash. Again, we have to calculate the value of inductance. This is switch, and from here only we are going to calculate the value of supply voltage, and this is the battery. Sorry, diode D. Everything is given. Now it is time to achieve the value of what? It is same circuit, same formula. முன்னாடி solve பண்ணல same model. A chopper circuit is shown in the figure. A resistor value is given, supply voltage is given, battery voltage is given, average output current is given, frequency is given. Now we have to estimate the value of, find the value of inductor for which the maximum ripple current will be achieving only 20% of the IL. Don't focus on any other values. See, this value is 0. Forgive me. It is not 10. Okay, everything is given here. Now what is the question? Just we have to, I think same formula. The first solve பண்ணல அதே question தான் இது. Nothing is changed. You can write down that same formula and you can again solve it. You know how to write, what is the expression for maximum ripple current? இப்போ கூட பார்த்தோம் last question கூட, right? You can try this question by yourself. That's not a big deal, and drop your answer in our Telegram group, right? I hope you all understood.